Welcome students. Today we are going to see the performance of the experiment to determine humidity of air by wet and dry bulb method. So for this experiment we will require, in apparatus we require only glass rod, in equipments we require psychrometer and psychrometric chart, and in chemicals we will require only water. Now let us see what is exactly wet bulb and dry bulb methods. So wet bulb temperature is the temperature of the stream of air which is cooled to saturation, that is 100% relative humidity, by the evaporation of water containing in it, and this cooling is done by the supplied latent heat by the stream of the air. Now consider the stream of air which is unsaturated by and air passing over a wet surface. Then water from the wet surface, it tends to evaporate from the surface of air, which increases the moisture content of the air, and hence the air will become saturated. The driving force for evaporation here is a partial pressure difference between dry, that is unsaturated air, and wet surface. So due to evaporation of water from the surface, the temperature of surface decreases and the sensible heat, that is heat supplied for evaporation of the water, is supplied from air to wet surface. So initially, loss of heat due to evaporation of water from surface is higher than the sensible heat supplied by the air to the wet surface. Ultimately, steady state will reach when loss of heat due to evaporation of water from surface is equal to the sensible heat supplied by air to wet surface. So at this state, temperature of water remains constant, and this temperature is called as adiabatic saturation temperature or wet bulb temperature. Now let us see how this experiment is performed. So this is the psychrometer.
This is a psychrometer. A psychrometer is a type of hygrometer and which is used to determine the relative humidity in the air with the use of two thermometers. If you look at this carefully, it has got two thermometers. This is called as the dry bulb thermometer and this is called as the wet bulb thermometer. This dry bulb thermometer, it helps to measure the temperature of exposed air, which is recorded as dry bulb temperature. And this wet bulb thermometer, it measures the temperature when the bulb of thermometer is dipped in a liquid. So, by comparing between the temperatures of both the thermometers, the individual or we can determine the relative humidity of the surrounding by calculating difference between the two temperatures. Now, this psychrometer, it has got this handle and this is a case. Okay. Now, in this case, two thermometers are fixed. One thermometer is open to air, or we call it as dry thermometer, whereas this wet thermometer, it is encased in this casing of the cloth. If you look at it carefully, it is nothing but it is a cloth. Okay, the cloth is wrapped here inside this casing. Okay, so this is the wet bulb thermometer and this is the dry bulb thermometer. Now, this wet bulb thermometer, what we are going to do, we are going to wet this we are going to wet this cloth, and due to the action of capillary, the water, it will rise inside this whole length of the cloth. Okay. Now what happens if you look at it carefully, this end of the thermometer, it is enclosed inside this cloth. Okay. So because of the movement of water due to capillary action, this thermometer, it will be surrounded by the water around it. Okay. So now let us perform the experiment. This lid we are going to open and we are going to add, if you look at this now, this lid it opens. Okay. If you look at it carefully, the cloth, it is wound inside. Okay, now first we will fill this gap or this chamber with water. Okay, so that the water will rise with the capillary action.
So
now
we have
first we will check the temperature in this dry bulb. The temperature in this dry bulb is 26.5. This is the atmospheric temperature, and we will wait for some time so that the water, it will rise in this capillary, and this bulb, this wet bulb, it will be surrounded by the cold water. So we will wait for so that this cloth, it gets wet. Now as you can see here, this cloth, it has become wet, and so we can say this bulb is surrounded by the wet cloth. Now we will whirl this psychrometer with the help of this handle for 15 to 30 seconds like this. Immediately after whirling, we will note down the temperature in this bulb.
In this thermometer. Okay.
The temperature in this bulb, it is showing the reading of 23 degrees Celsius. So we will say the dry bulb temperature is 26.5 and the temperature of the wet bulb is 23 degrees Celsius. Okay. Now we will repeat this experiment for consecutively for 2 more times. Okay, and we will note down the readings.
So now this is the observation table. So here it consists of first the serial number, then the wet bulb temperature column is there, then average wet bulb temperature column is there, then comes the dry bulb temperature column, and then the average dry bulb temperature column. So as I've already told you that we are going to perform this experiment for 3 times. Okay, so the readings for the wet bulb were 23, 22 and 23. So the average is, the temperature of the wet bulb is 23. The dry bulb temperature was found to be 26.5, 26.5 and 26.5. So that was the temperature, or we can say that was the room temperature. Okay, so average bulb temperature is rounded up to 27 degrees Celsius. Now we will see how we have to perform the calculation. Okay, we are going to subtract this to temperatures. So dry bulb temperature minus wet bulb temperature. So dry bulb temperature is 27, wet bulb temperature is 23, and hence the difference is 4 degrees Celsius. Okay, so now this is our psychrometric chart. If you see this here, you have depression of the wet bulb in degrees Celsius, and here you have the dry bulb temperature. Okay, now our dry bulb temperature was almost around 27. So you will mark here 27. Okay, so this is 27, and depression in the temperature was 4. Okay, so at this 27 you will see what is the humidity for this 4 degrees depression in the temperature. Okay, so this is a very simple experiment. Now from this you get the value, and so the result will be the percent relative humidity in atmospheric air was found to be 72%. So this 72% we obtained from that psychrometric chart. Okay, so in this way we have completed the experiment. Thank you.